The amount of water vapor that air can hold increases dramatically at higher temperatures. Every 10 degrees Celsius increase in temperature nearly doubles the amount of water vapor that air can potentially contain, up to a maximum of about 8% of the mass of the air on a very hot day. Just because air can hold that much moisture doesn't mean it always does. It may hold none or some or all of that maximum amount. This is called relative humidity, expressed as a percentage. It says how much water the air actually contains compared to how much it could potentially contain. If the air temperature changes, the maximum amount of water vapor goes up or down, which changes that percentage even if the actual amount of water stays constant. If a parcel of air is cooled enough, the capacity will eventually decrease to be the same as the actual amount. The percentage will be 100%. The temperature at which this happens is called the dew point. It can be calculated from the current temperature and humidity. The dew point will always be equal to or less than the current temperature. It's the temperature to which air must be cooled to reach that 100% point, the point at which air will become saturated. This is answer B. Scientifically speaking, answer A actually does describe what happens physically at the dew point, but the FAA expects answer B. The temperature to which air must be cooled to become saturated is the standard, practical aviation definition of dew point, as discussed and described in FAA materials. The term dew point is a bit of a misnomer, which answer C uses as a distractor. A better term might be saturation point. If the air is cooled below its dew point, the air will be saturated. However, what happens next depends on the condition and the location of the air. If the air continues to cool and there is a convenient surface, some of the water vapor will condense into liquid water. If that surface is a blade of grass or a bathroom mirror, it will form dew. But if the surface is a particle of dust at 5,000 feet, it will condense into a cloud. And if the surface is below freezing, it may form frost or ice instead.